Hi guys, so today we are going to be taking notes on linear regression and predicting values. So hopefully you have your note sheet out in front of you and you're ready to get started. So first we need to talk about what scatter plots are. So scatter plots are just a graph basically of ordered pairs, and it's used to plot data to determine if there's a relationship between that data. So as you can see on this, we just have a bunch of random ordered pairs. And the point of scatter plots is to look at these ordered pairs and see if there's any type of relationship. So looking at that relationship is what we're going to be getting into next. So determining if there's any type of relationship is called correlation. If there's a correlation, it means there's a pattern within the data, and it means that we can use the data to predict something. So the three kinds of correlation that we can have. The first is positive correlation, and that's where your y values tend to increase as your x values tend to increase. So as you can see, it kind of makes an uphill pattern within your dots. The second kind is negative correlation, and that's where your y values go lower as your x values increase. And as you can see, that kind of makes a downhill kind of pattern with your ordered pairs. The last kind of correlation is no correlation, where there's just a bunch of random ordered pairs, you don't see any relationship, and that means that y does not have any kind of relationship with x. There's no pattern, the variables aren't related. So some real-life examples that we can talk about to show positive, negative, and no correlation. Let's look at the first example. So say I want to make some cookies, and I make them on Tuesday. And let's say I start with 14 cookies on Tuesday. So we'll say up here at 14. Maybe 2 days after I make the cookies, I only have 10 cookies left. And 4 days later, I only have 6 cookies left, and so on. So my ordered pairs get lower and lower as the days increase. So this would be an example of negative correlation. All right, let's look at the bottom example. So this one is comparing the amount of time you spend studying on a test to the grade that you receive on that test. So hopefully, the more time you spend, the higher your grade will be. So say if you only spend 10 minutes studying, you might get a 70%. But maybe if you spend 20 minutes studying, you'll get an 80%. Or if you spend 30 minutes studying, maybe an 85, and so on and so on. So the more time you spend, hopefully the higher grade that you're going to receive, and that makes some type of positive correlation, because as your x values increase, as your time increases, your grade increases. And the last real life example is we're looking at no correlation. So how fast you run, we want to look at how that affects how many shirts you own. And if you think about it, how fast you run is going to have no effect at all on how many shirts you own and vice versa. So someone with 20 shirts might be really, really slow. But then you might have someone with 18 shirts who runs extremely fast. And you could have ordered pairs all over the place because there's really no connection between the number of shirts you have and how fast you can run. So this is an example of no correlation. There's no trend, there's no pattern, you can't see anything with your ordered pairs. So on your notes, after we're finished with this, I want you to think of 3 real-life examples where you can think of negative correlation, positive correlation, and no correlation being shown. All right, so this leads us to our line of best fit. So the line of best fit is the line that has the best fit with the data in the scatter plot. So when we look at all of these ordered pairs here on our scatter plot, and we want to draw a line of best fit, it's going to be a line that fits within these data points. So when you're doing it by hand, which we won't do it too often, but you have to know how to do it, you need to draw a line that's going to have about as many points above the line as you do below the line. So let's say I draw my line here. And let's count. I have 1, 2, 3, 4, 5, 6 points above, and 1, 2, 3, 4, 5, 6 below. So that's a pretty good estimate of your line of best fit. Same thing over here. You're going to try to want to draw a line that goes through your data and kind of splits it right in half. So we would have 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, 6 above. So to get an exact line of best fit, we're going to use our calculator, and you're going to see how to do that on the next video. But you have to know, when you do it by hand, the goal is to get as many points above the line of best fit as you have below the line of best fit. So our last definition today is linear regression, and that's the mathematical process of finding the line of best fit. So let's look at an example. We want to find the line of best fit for the data in this table below by plotting the paired data onto our scatter plot. So as I'm going through and doing this, you should be doing this on your notes as well. So our first value is when x is 1, y is 4. So that's going to give us the ordered pair 1, 4. So let's put that onto our graph. Next, we have 2 matching up with 6, which is going to give us 2, 6. 3 is paired with 7, so 3, 7. And so on. We should have 4, 9. 5, 10, and also 6, 10. So go ahead and take a second and finish plotting your points onto your scatter plot. All right, so just looking at our scatter plot, you can tell that there's a positive correlation because as your x values are increasing, so are your y values. So we have 1, 2, 3, 4, 5, 6 total ordered pairs. So if we were to draw a line between them, we want to try to get 3 above the line and 3 below the line. So let's do that. It might be a little bit tricky. So here we have 1, 2, 3 below, 2 above, and 1 that kind of falls right on our line. So again, doing it by hand isn't the best, but watching the next video, you'll learn how to do it on your calculator, and that will always get you the exact line of best fit. So this is a question that you might see on a quiz or an SOL, and it's going to ask you which equation would most closely represent the line of best fit for the data in this table. So looking at our graph and our line of best fit, we know it's positive, we know it has a positive correlation, and we know the line is going to have a positive slope. So just looking at A and B, we can see those slopes are negative. So we can automatically eliminate those two as options. So let's check out choice C. Choice C says we have a slope of 4 over 5 and a y-intercept of 3. So if I had a y-intercept of 3, I'd be starting here. I'd be using my slope to go up 4 and over 5, which is kind of close to our data, but let's see if the other one gets any closer, because we want to pick which equation most closely represents. So the last choice tells us our slope is 5 over 4, and our y-intercept again is 3. So we'll start at 3 again. This time we're going up 5 and over 4. So as you can see, our blue dot is closer to our line of best fit than the red dot. So our answer here would be D. This equation most closely represents our line of best fit. All right, and this is the final step of using lines of best fit. So the reason we want to make up this equation and have our line of best fit equation, which we determined was y equals 5 over 4x plus 3, is to use this line of best fit and to use this equation to predict things. So it says, based on our equation of the linear regression, predict the value of y for when x equals 8. So all you have to do is take x equals 8 and plug that into your equation. So we're going to have y equals 5 over 4 times 8 plus 3, which gives us y equals 5 over 4 times 8 gives us 10. 10 plus 3, so y equals 13. So when x equals 8, y equals 13, and we can think of that as an ordered pair if we want. 8, 13. So somewhere on our scatter plot, we would have a value, an ordered pair at 8, 13. And hopefully it would either be right along or very close to our line of best fit. Okay, so today we talked about correlations, scatter plots, and lines of best fit. You have an example on your notes that I want you to try and bring into class tomorrow, and if you want to watch the next video, that will show you how to create this linear regression on your calculator.